In this video, we are going to review the adding and subtracting of rational expressions. So remember, a rational expression is when you have polynomials that are written in fraction form. So I've got 1 over 4x squared plus 3 over 6xy squared. Okay? Now, when you are adding and subtracting rational expressions, just like when you're adding and subtracting, regular fractions, you need to have common denominators. Okay, so I'm going to need to find common denominators between these two fractions. Okay, but before I do that, one thing you can always do, which might make your job a little easier, is to look, is there any way I can simplify either of the fractions before I even get started? So if you look at the first fraction, there's nothing I can cancel out because it's 1 over 4x squared. But the second fraction, I've got this 3 on top and this 6 in the denominator, and obviously 3 goes into 6 evenly, so I could cancel this 3 out, turn it into a 1, and cancel this 6 and make it into a 2, okay, because 3 goes into 6 twice. Now you don't have to do this right away. You'll end up with the same answer at the end, but you'll just have to simplify later if you don't. So okay, so now that we've got simplified, let's look and see about common denominators. So I'm just going to take this one step at a time. So I'm going to start with looking at the coefficients in each denominator. So I got a 4 in the first fraction, a 2 in the second fraction. So obviously 2 goes into 4, so my common denominator will have a 4 in it. Okay? Then I look at the x's. I got x to the second in the first fraction, x to the first in the second fraction, so I'm going to need an x squared. Generally speaking, when you got variables, you're going to need the highest degree variable to be in the denominator because you need something that both denominators can go into. So x squared can go into it itself, and x can go into x squared. All right, and then as far as the y's go, I have a y squared in the second denominator and 0 y's in the first denominator. So I'm going to need a y squared. Okay, so now that I have my common denominator, which will be 4x squared y squared, I need to go about changing both fractions so that they match this denominator. So if I look at the first fraction, I need a 4 and I already have a 4. I need an x squared, I already have an x squared. I need a y squared, which I don't have. So I'm going to need to multiply the denominator of this fraction by y squared. But of course, when you multiply a fraction's denominator by something, you also need to multiply its numerator by the same thing. Because when you're multiplying fractions to get a common denominator, what you really want to do is multiply by 1, so you're not actually changing what the fraction is. So I'm going to multiply the top and the bottom by y squared. Alright, then on the next fraction, I've got a 2 and I need it to be a 4, so I'm going to multiply the top and the bottom of this by 2. Okay, then I have an x, which I need to make into x squared, so I'm going to have to multiply by an x to the first to change my x to the first into an x to the second. And then I need a y squared, and I already have a y squared, so I don't need to multiply by any y variables. Okay, so I'm just going to multiply and down here. Remember, when you multiply fractions, numerator times numerator, denominator times denominator, so y squared times 1 is y squared. Y squared times 4x squared is just 4x squared y squared. Okay, 2xy squared by 2x on the next fraction is going to result in the same denominator because 2 times 2 is 4. X times x is x squared. And then I still have this y squared here. Okay, and then in the numerator I've got 1 times 2x, so that's of course just 2x. Okay, so I end up with these two fractions. Now remember, when you add fractions, as long as they've got common denominators, which these two now have, I just add the numerators together and the denominator stays the same. So I end up with y squared plus 2x divided by 4x squared y squared. And that is as far as I can go because I can't factor the top at all or the bottom, so I can't cancel anything out. So I'm done. Okay. All right. Moving on then to the next example. Got 5 over a plus 6 over a minus 4. So once again, I need to find common denominators. Notice there's nothing I can cancel out right away, so I can't simplify the problem. So I'm just going to go ahead and try to find common denominator right away. Now, be careful here, because here's what's a mistake I see is students will think, well, I've got an a here and an a here, okay? So I just need to subtract 4 from the top and the bottom of this fraction so that I'll have a minus 4, but you can't do that. You've got to get common denominators by multiplying the top and the bottom, not by adding or subtracting anything, okay? So the common denominator is actually going to be, it's going to consist of each of these factors. So it's going to consist of a times a minus 4. In other words, I got two denominators which are different, so the common denominator will just be both denominators multiplied together. It'll just be a times a minus 4. Right? Now to get that common denominator, this first fraction already has the a, so it needs the a minus 4. So I'm going to multiply the top and the bottom of this fraction by a minus 4. Okay? Now this fraction over here already has the a minus 4, but it needs the a, so I'm just going to multiply the top and the bottom of this fraction by a. Okay? So now I'm just going to simplify. So on this left fraction here, I'm going to go ahead and distribute this 5 across the parentheses here. So that will become 5a minus 20 over a times a minus 4. And then over here, I just have 6 times a. So that becomes 6a over a times a minus 4. Okay, now that I have common denominators, I can go ahead and add the numerators together, and I got a couple like terms. I got a 5a and a 6a, which I can combine together. So my final answer over here is going to be 11a. I still have this minus 20 over a times a minus 4. Okay, and that's about as far as I can go. If you really want to, you could distribute this a across the denominator to make it a squared minus 4a, but you don't really need to. This is simplified right now, so that is as far as I can go. All right. Last example down here. So I got a subtraction. So I've got a fraction on the bottom, or on the left I mean, which is a divided by x squared minus 3x minus 18 minus 1 over x minus 6. So I need to find common denominators. Now to find common denominators, you want ideally both fractions to be as factored as you can get. So this fraction's already, it can't be factored, it's just x minus 6. But this left fraction got a trinomial, so I may be able to factor it. In fact, it looks like I can, because I can got x squared minus 3x minus 18. So remember, I'm looking for two numbers that multiply to negative 18 but add up to negative 3. So that is going to end up being minus 6 and plus 3. So this factors into x minus 6, x plus 3. Okay? So if you look over here, they do share one factor in common, but this right fraction is missing the other part, which is the x plus 3. So the common denominator is just going to be x minus 6, x plus 3 will be my common denominator, which means this left fraction already has that denominator, so I don't need to do anything. But this right fraction, I need to make it into this, so I'm going to have to multiply the top and the bottom by x plus 3. So x plus 3 on the top, x plus 3 in the bottom. Okay, so then, so once again, this left fraction, I'm not going to change it all. I'm just going to leave it as 8 over x minus 6, x plus 3. This right fraction, I'm going to distribute this 1 across, which won't change anything, so it'll be minus x plus 3 and then the denominator is the same. So x minus 6, x plus 3. Okay, so now I can go ahead and combine these fractions together, so I can subtract this numerator from this numerator. So I got 8 minus x plus 3. Just be careful because this negative sign applies to the entire numerator, so it's minus x plus 3. So when you think about this, you might want to think about distributing the negative across. So I'm going to end up with 8 minus 3 instead of 8 plus 3. So that will result in a 5. And then minus x is positive, but the minus sign made it negative, so I've got 5 minus x on the top, and in the denominator I've got x minus 6, x plus 3. And I would just go ahead and leave the denominator in factored form, and I can't cancel anything out, so this is as far as I can go. Okay, so just be aware that all the regular fraction rules apply when you're working with rational functions. You must, when you're adding and subtracting, you must find a common denominator first.